Right, fine. You guys asked for it. I deliver. By you guys, I mean my friends at college. I'm looking at you, Neha. Anyway, in this video, I'll go through how to design a simple stool.
Let's do this.
We start off by making a new part and me making my first mistake already. Cause you know, I'm a freaking idiot. I didn't pay attention to the opening dialogue and set all the measurements to the imperial scale. Crap. After a bit of research, I found you can just change it here. Let's look at the blueprint, which isn't blue or printed.
Huh?
First, let's create a new sketch. This sketch will define the shape of our seat. Naturally, I select the top plane to create our sketch. What, you don't know why I'm using the top plane? What are you, 5? If you look back to our non-blue blueprint, our seat is basically a really flat cylinder. Looking at it from above, you will notice it has a constant cross-section of a circle. So creating a circle on the top plane and then making it 3D is probably the easiest way to go about making our seat. So here I've quickly drawn a circle and now I'm gonna make its center coincident with the origin to keep it in place. The diameter of the seat is 300mm, so I'll define that using Smart Dimension. Our seat is also 3D and not a flat circle, so we'll use extruded boss to make it 25mm thick as required. Now some of you may be screaming, but the cross-section isn't constant, it's curved at the top and bottom! Shut up! But yes, it is curved with a radius of 5mm. This means that if the curve was part of a full circle, that circle would have a radius of 5mm. So we use fillets. We done it.
Congratulations, it's a celebration.
Now onto the legs. I don't know if you've noticed or not, but they are long cylinders attached to the seat at an angle of 15 degrees. So let's make that cylinder. But how? Let's talk about planes. Remember that to make a cylinder, it's best to have an angle from which the cross-section of the cylinder is constant. Well, in this case, we can't get that angle. Not without some serious firepower. By that, I mean reference geometry. Right now, neither the front, top, nor right plane gives us a constant cross-section. Reference geometry allows us to make our own geometry to use as reference, hence the name. So, if we make a plane similar to the top plane, but tilted at an angle of 15 degrees, our job would be a lot simpler. There's just one problem. I suck. After some decision making, I selected the right plane to create a line that would define the first of our reference plane's axis. You know what I'm talking about, right? No? To create our plane, we need to tell the computer where it is and how it's oriented. Pretty simple. Until you end up with a piece of Anyway, first we'll define the slope of the plane, which is at 15 degrees to the horizontal, using a construction line. For any smooth brain viewers, that's the centerline button. While it's not necessary, it's good practice to fully define construction lines as well. Since we don't care too much about the length, we'll just make it infinite. If we try to make the plane using the construction line we made, you'll see that the computer has a pretty good idea on what we want. But it's not fully defined. So, like a moron, I spent another 5 minutes trying to fully define it using existing features. Unsurprisingly, I failed. Overall, it took me 20 minutes to figure out that I had to create another construction line perpendicular to the first line to make it work. Learn time. A plane is a 2D object. 2D means two-dimensional, so a plane has two dimensions. Most surfaces in real life are two-dimensional. This wall has width and height. This page has width and length. Just like that, our plane can be described as having an x dimension and a y dimension. If we define them, our plane can exist. We've already defined one of our dimensions, so let's define the other. I select with full confidence the top face of the cylinder to make my sketch. This was a terrible mistake. Once I made the construction line, I went to make the reference plane, and this was the result. This is in fact not the plane I wanted. This is also when I realized that the two construction lines must be intersecting for this to work. Remember that top face I used to make the sketch? Yeah, so the first line goes to the origin. You know what else goes to the origin? Not the top face! The origin is actually intersected by the bottom face. In about 5 minutes, we were back on track. Back to the legs. Now that we have the angle, we just need to create the circle to extrude a leg from. As you can see, the legs are positioned in a circular pattern with a diameter of 140 millimeters. So, let's make that sketch. Now, a bit of stupidity on my part. I decided for whatever reason to create the circle to extrude the leg from on the same sketch as the circle the leg is aligned with. That was stupid. I should have made that on the same plane that we had just made previously, which was angled at 15 degrees C. This cost me valuable time that I could be spending with my imaginary girlfriend. I'm just kidding, it's a boyfriend. More on that later. No, not the imaginary boyfriend. He's my coping mechanism, you don't have a say about him. No, what I mean is that to make the legs, we need to consider one final piece of information. If you look here, the blueprint shows that the legs are flat at the bottom. Look closer. The bottom face that would be in contact with the ground is parallel to said ground. That would make sense, so we need to make another plane that will define the alignment of the bottom face. Oh, I forgot to mention, the blueprints do not give us the length of the leg, only the distance from the top of the seat to the ground. So we'll need that plane for that too. Let's get that plane. Now that we have the plane where the leg ends, it is time to create the leg. Or so I thought. Back to the mistake I made earlier, I made the circle that will define the cross-section of the leg on the wrong plane. This is where I realized my mistake, questioned my existence for a bit, and redraw the circle on the angle plane where it's supposed to be. Finally, it is time to create the leg. I hit Extrude Boss, select the bottom of the seat to define the start of the leg, select the plane where the leg should end, and it doesn't work. What the? Even I'm confused. After a bit of fidgeting with SolidWorks, I got it to work by first using the sketch plane to start the leg, select the plane where the leg should end, and then went back to change the start plane to the bottom face of the seat. Weird. Now that we have one leg, it is time to use a neat trick that will allow us to make the other legs without nearly as much effort. I introduced you to circular pattern. Quick question, how many lines of symmetry does a circle have? In this case, it has as many as we need. So if we draw a line that cuts through the center of the seat, we can copy the leg around the seat using the line that cuts the seat as a line of symmetry. So let's make that line of symmetry. And now for the circular pattern. Hit the tick and we are done. Finally,